Hi there, welcome to Dave in the Shed. I'm Dave and this is my little corner of the world, also known as the Shed Mahal. Now if you're into DIY, 3D printing and model trains, you've come to the right place. Now fair warning, I do things a little bit differently. I have cerebral palsy, which means sometimes things get a little bit creative around here, but hey, it just makes it more fun. So if you like making, fixing, and maybe even breaking things along the way, stick around. Hit that subscribe button and let's build something awesome together.
Down in the shed where the magic begins, Dave's got his tools, let the fun commence. 3D printing dreams, watch him come alive. With every little gadget, man, he starts to thrive. Blueprints in hand, technology so keen, building up the future like a crafty machine. Model trains rolling on a whimsical track. In this shed of wonder, there's no time to slack. Oh, Dave in the shed where the vibes stay high. Creating with passion, he's reaching for the sky. DIY master in a vibrant samba flow. Hope you enjoyed the video, let's get ready to go. Let's get ready to go.
Well, welcome to another video from Dave in the Shed. Last week, I apologise, I made a real bumbling idiot video. I didn't really explain half the stuff that I wanted to do. I was having hassles enunciating the King's English, and it really got a bit bizarre. So let's start again. Let's try and do it again. I have opened up a packet of these Aldi Christmas lights. Well, they came from Aldi, they are from other sources. These are an unmolested kit. By what I mean by that, I have not played with them, I have not done anything fancy. All I've done is put some batteries in there and turn them on as they come out of the packet. Now, the reason is to show you what they look like out of the packet. Before I do any tinkering or playing around, running off a set of batteries, that's how bright they are. They're not that bright, they're not that brilliant. All the shed lights are off, so this is just daylight that is coming through the shed and filming this as a sort of like a before we start monkeying around. Now, this YouTubing and doing stuff is pretty hard work. I have worked out and learnt how to use the software so I can remote control the camera, so I can do more of showing you what I'm working on. The only hassle is I can't run my fancy little microphone and the app at the same time. It doesn't work apparently. So this could be interesting. So I could have to do some fancy editing and doing stuff. I think I can still record on the mic at the same time, but I can't actually do the trick where I'm doing now where the mic feeds. Anyway, you don't need to know the technical background, but we will rock on. So I've got to do some tests. I just assumed that even though the battery box had changed, all the other light stuff was the same, but I didn't test properly, did I? So what I'm going to do is, and I'll tell you what I'm doing in a sec. So anyway, let's pause this here, and I've got to turn my big lights on so I can do some work. So here is the set of lights, and they're all running. Shed light is on, so they're under normal house light constituents, shed light. This is the set that I've been using to pull apart and to pull the lamps off to do our conversions with. So what I'm going to do is, I'm going to show you this, hopefully record this. I'm going to pull the bottom off one of these lamps. We're going to expose the wires on the bottom, on camera hopefully. Going to expose the bottom on camera. Oh, Dave, get yourself in trouble. And we're going to measure the voltage on the string of lights, because I've got a funny feeling that the voltage on the lights is different to what we had before. So anyway, let's try this. Pause the video and we'll see what happens next. This is all super complicated. All I want to do is record a video. Anyway, got the lights here running off this battery pack. What I plan to do is I'm going to, hopefully, with you watching me on the videos, I'm going to slide this cover off. This cover just pulls off the bottom, off the bung. So hopefully I'm just going to pull this off, flick it off with a whatever I can grab, probably the a Stanley knife that I haven't got here. I've got to walk over there and then get, and we can then expose the wires, and then we can put a multimeter across the wires. Hang on, back in a sec. Talk about yourselves. In reality, that was just like instant done, and now I bumped the camera stand and ruined the shot. But anyway, got the Stanley knife. Very carefully, going to flick this bung off here. If you see blood spurting out or a scream, you know I've cut myself quite severely. Try and do this. So, this is something I should have shown you the other week, and I didn't. These poles are a bit fragile. You do have to be careful. Okay, so I don't know if you can see that, but I've lifted the end up now with the knife, and I can just get in there and flick it out. Now, a bit of hot glue holds these cables in. See that? Now, if you are careful and gentle, you can tease out the joint. There is a joint underneath that hot glue. There is a joint between the white cable. It might not be easy to do this on camera. I might have to stop videoing, showing you. But you need to carefully tease out all that hot glue, which I'm probably not going to record me doing because it's going to take me about 15-20 minutes to do it and struggle and probably cut a finger off. But anyway, let's just pause the video and I'll be back with you when I've teased it out to show you what I've done. Well, I've fiddled and fuddled with that. You're not going to believe that, but that's just not wanting to do what I wanted to do. What I wanted to do is, here's one I've done earlier, is I wanted to expose the base, because underneath the hot glue is a joint where those wires are just soldered onto that white cable. And it's all held in a place with a bit of hot glue, and if you're very careful with a knife or a pair of nippers, you can pull the exposers out. So if you don't want the white lead, you can just cut them there, depending on the situation, and you could then remove those, and we'll have a look at doing that process, and solder my resistor to run the lights on straight onto that base. If you're using a situation, installing on your layout or your situation, and you didn't want this white cable, you could expose that and just solder your limiting diode to there, which we will do in a sec on this one, on the one I prepared earlier. Okay, let's just pause here for a sec. Now I've just done some off-camera magic. What I've done is I've just cut that light off. In the end, I was trying to struggle to get that light off, and I couldn't get it off, and I was struggling and buggling, and in the end, look, I've just done. What I want to do is I want to measure the voltage on this string of lights. As you can see, they're connected to the pack. The lights are on. Now, we already know from my experiments that if you look very carefully on the ones that I've been using from Aldi, I don't know if this will focus. I can't see running this if the thing is focusing or not. There is one goldy one and one silver cable. Now, I know from experience that the silvery one is the negative and the goldy one is the positive. But what I'm going to do is I'm going to put my multimeter, I'm going to put it on voltage. Now, my lowest DC volts, this is DC fully line over here. See what the finger's pointing? Can't see. Anyway, this is the DC volt settings over here on this meter. You can tell by the constant line, because DC is direct. Over here on the other side, see this one, this is volts full line, V for voltage. This one is squiggly line over here, which means the AC, because it's alternating. If you understand voltage, that makes sense. So this is the DC, the solid line. Now I know this is, in theory, this is going to be more than 5 volts or 4.5 volts, because there's 3 1.5 batteries, but I don't know. So anyway, we'll go to 20 volt. We should not have blown up the meter. If I went on 2 volt, the meter would have a heart attack. So lucky with these meters, with the old analog meters, if you connected the wires around the wrong way, they'd go backwards, which is no good. This one I know, even if I get the volt around the wrong way, it'll just tell me that it's negative. Okay, so that's negative 2 volts. So let's swap the wires around across here. So I've got to put the wires around the other way on my meter, and I'm measuring what is coming out of that voltage pack. Now, see, this is interesting. It is telling me that it's putting out 2 volts on that line, which means those batteries are not in series. I was assuming we had 3 1.5 volt batteries in series, giving us 4.5 volts. But these are in parallel. So we have 2 volts because those batteries are in parallel. Even though they're 1.5 volts, they're fresh, they're powerful. So the amount of resistance that I put on my line is why when I put the big resistance on there, it didn't work. It wasn't working properly because I was assuming, not measuring, that I had, assuming, us out of you and me, that I was dropping, down. I don't need to. So my voltage drop is different. So that's why I had to use a less impedance resistor than what I was using, because I'd done my calculations on the size of resistor based on that I thought I had 4.5 volts on my line. I have 2 volts DC. So we are going to rock on with the resistors I'm using because they work fine, but that is why they were not as bright as what I expected, because that's those batteries. Interesting. If you want to know why in a complex lesson about electronics and series and parallel, just look it up online, don't look on me. But, so as these lights are running off 1.5 volt, not 4.5 volt that I'd based all my calculations on. It's all scientific. Don't worry if you don't know what I have no idea what I'm talking about, but that's what was going on. That is why I had hassles last week with my resistance in line, as in my protection resistor. And it was way too big and it wouldn't work, and I just got myself in a mess. But anyway, very didactic, very long. Let's rock on with what we're doing, Davey. Now remember last week I said it does not matter if you're worried about this and you don't have access to a multimeter and all the stuff. It doesn't matter which side that protection resistor goes in the line. It doesn't matter, okay? So here we are, we're back using these lamps. Now I know that they're running off 1.5 volt technically. That is why the protection resistor didn't work. So I'm now pumping 6 volt. Well, close to 6 volt, that'll do for our purposes. 6 volt into the system, into this LED. Now, for experiment purposes and to show you what I mean, I have put that protection resistor in the negative line, okay? So if you want to use these things and you're not really sure, all you need is the right size resistor. Now, these new lights from Aldi, the ones that they've been selling this year and the updated, they are running off a 2 volt system, not 4.5 as the old ones. This is where we stuffed up. I just jumped in and said, this is what I've done before, yada, 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 and it all went pear-shaped. I should have done some testing. Should have done some testing, Dave. Anyway, so we have our dropping resistor, which is 100 ohm resistor in compared to the 1000 ohm resistor I used on the other system. So this one, the resistor is in the negative line. See that? That's in the negative line. The LED lights up. And so it doesn't really matter which side that protection resistor goes on in the circuit. It's got to be in that circuit. That's all you've got to do. Got to have it there. It stops us it means that we can pump 6 volt. Now, if you're running 12 volt on your supply for your accessories, we do have to put a different resistor in. If you'd like to know which resistor to put in, let me know and I'll tell you. But because I'm running 6-volt bus, accessory bus, lighting bus for all my lights, because they're LEDs, I have to use this size. Doesn't matter which side it goes in. And I'll show you what happens if I reverse connect the diode. You're asking. Well, I'll show you what happens. So we've reversed the current input. Look at that one. I'm now got the positive on that diode. I have now got the negative on the diode. So this is so if you don't have a multimeter to work out which side is your positive and negative, don't panic. Just as long as you put that protection diode in there. And if you reverse connect the polarity, what happens? Well, nothing. Nothing happens. Literally, the light doesn't go on. Now, to prove that it's not stuffed, look, I'll do this live. This is a bit hard for me to hold the camera and do this, but anyway, undo that one. Undo that one. Let's go the lead back onto that negative. Let's go that, and you saw that it was reverse connected. You won't see this video if it doesn't work. That's why I struggle with holding the camera, because my left hand don't work too well. Okay, so you saw me, I had that reverse connected, reverse polarity connected. I've just reversed it back the other way around, and it's working. It's working. So don't panic about not having the protection right, as long as that protection diode. Now, I know a lot of people out there want to see what happens if I don't have the protection diode in circuit. Well, no, I've blown up enough of these lamps. I don't need to blow anymore. I want to keep some working. But we'll talk about in this video what to do with the blown up ones in just a second. So this is one of the lamps that I've blown up. And what I've done is I have broken it off the post, or pulled it off the post. I drilled out, whoop, the cable's come off, drilled out the little fitting, and I put one of the lamps I had on hand, which now, this is a LED which is designed to run off 12 volt. We talked about last week about getting the thing. So this is, I haven't got any 6 volts left, so I've ordered some. So what I've done is I've drilled a hole in the bottom. I have jammed a 3mm white LED, which is designed to run off 12 volt, but I'm running it off 6 volt, so it's not going to be super bright. And we end up with this. Now, what it means is if I really wanted to and I was careful, I could put new LEDs in those systems, the ones I blew up. But no, we're not going to do that. But there, if you just want a lamp, yellow is better depending on the type of lamp, because yellow represents a gas lit flame better than what we're talking about. But that's one I played with, and I rebuilt it. It's my connection's not good on the thing, but that is running off the bench supply at 6 volt. Well, as good as 6 volt. And I've refitted the LEDs. So in theory, if you wanted to, you could then refit the posts and do all that. But that's not what we're doing about. It's just about how using these lamps and doing the bits and pieces. Okay. So what I've got to do is get on with soldering protection diodes into my street lights. You've seen me doing that, but I might quickly do that off camera and let you know, but I might solder them up. So what I'm going to do is I use them on the white cable because it's just easier. And then I solder a protection diode, normally, technically, on my negative side, and then I can install these street lights on the layout. But anyway, I'm going to pop on with that now. Talk to you soon. Now, I might have to do an autopsy on this battery pack, because I don't know if we're trying to zoom in and show you, but on the side it says that this input here is like 4.5 volts. But clearly, we know that the output voltage from this battery pack is not 4.5 volts, it's 2 volts. So in here there must be some dropping resistor. So I might, this is the one I've cut off. This is the disused one. This is not off. This is off. I've cut all the lights off this string. So this is surplus to our needs. I might try and pull it apart and see what's inside and autopsy it. Come on, focus and get settled. Anyway, it clearly says that it's a 4.5 volt input if you use that coaxial voltage power inside to run these lights. Even though it's, yeah, so I'm going to pull this apart, just out of interest. I've just pulled apart that battery pack. I'm glad I did have an autopsy, because what I was saying was wrong. If you look carefully here, this is the output line over here that feeds the string of lamps, and in there, just before the power leaves the battery pack, have a look at that. There is our protection diode. There is a protection diode. That is the diode that is stopping that battery pack, sorry, the protection resistor. There is our current limiting resistor, which is protecting this battery pack, frying those LED lamps in that string. There you go. In there. Now, I can't really read that. I'll actually put in the video. We'll work out the ohmage of that resistor. I'll whack at my book and I'll put it on the screen. Editor Dave will put up the value of that resistor, because that then is the perfect resistance that you need to protect these things. But I thought this battery pack was actually the, look at this, interesting. These batteries sit in a line like that. I thought, by looking at that, they're actually in what we call parallel, but no, they are series wired. So that it is 4.5 volts from the battery, 1.5 volt batteries in series. This is our series wiring, these white wires, coming up to that switch, but there is current limiting resistor, so those batteries don't fry the line. So that is why we're putting 4.5 volts out of our batteries, and this little unit there, that little current limiting resistor, is dropping the supply that is coming out of that battery down to 2 volts. So Ohm's law, for all the Sparkies and all the people out there know the difference. If you're going to use those LED, long way around to get to this end of the story, if you're going to use those lights, you need to have some way of dropping the supply down to a 2 volt for the lamps. But there you go. Should have done that ages ago, 2 weeks ago, saved all the trouble. Anyway, if you wanted to, you could pull that resistor out and use that. That's one less resistor you have to put in your circuit. Or if you're doing a whole series of lamps on the string, now I de-string them because I want to put them individual, you could just then pull that out. Now, if you've got any questions about any of what I've rambled on about, please do ask. Please go, Dave, what are you on about? Can you please explain it better? What you're doing, why? Because I tend to rabbit on. But if you're using, I can't even think of the brand of the light. Anyway, if you're using that particular lights in your Christmas lights, they're a common light accessory. You can get them off the internet. You don't necessarily get them out, but those particular lights, look at last week's video. If you want to know all about the lights and the brand, or I can put some details in here because I've got the thing. If you're going to use that particular lights, they are a 2 volt LED, and you have to put in a resistor that lowers your voltage or limits your voltage to 2 volts, or you will fry the lamps. And there is, in that battery pack, if I'd pulled it apart last week and had a look at what the guts were, I would have known, and we wouldn't have had all these hassles. But there you go. You live and learn. Well, this is just a little bit of trivia. What do they call it, for shits and giggles? I know that is now a 39 ohm resistor. I've whacked it under magnifying glass, done my calculations. I was trying to read the resistance to check my calculations with the meter. Oh, we've got the strobing back again. Oh, strobing's caused by the refresh difference. Hang on. Well, Dave back rabbiting on. Now, I humbly apologise because some of the video I shot earlier will have the strobing issues with the refresh rates from the camera when the shutter speed of this Osmo Pocket 3 and is not set right, and you see the strobing from the LED lights. Look, I humbly apologise. I've got to spend some more time reading some manuals. Why that was happening for those people who has the Pocket 3 is when I remote control the camera from the phone, the default settings have to be programmed in on the remote control on the phone. Otherwise it shoots that. So the settings that I had in the camera for when I'm using the camera handheld is fine, but when you go to remote, apparently it overwrites your default settings and you've got to have the default settings on your phone to what you want to shoot. That's just crazy. So when you're using the remote function on the Osmo Pocket 3, you've got to reprogram all your settings on the phone, in the software on the phone. So I'll have to play with that later. Oh, all this frustrates. Anyway, done some Mickey Duck calculations. I can tell you now that is a 39 ohm resistor. I'll order some before we go on with the streetlight projects. I'll probably get the right ones and get it all set up and get it Mickey Duck. But what I was going to do, I was checking my calculations with the multimeter, my old one, jiggy poker, because I've got to swap hands. And I was checking here. This is where it's going to be handy to work out what's going on. And this old meter, I'm going to try and show you, it doesn't like reading that, even though this is on the 200 ohm scale, the lowest ohm measuring resistance here, resistance scale. This old meter, we're going to measure our resistance at lowest scale settings down here. Oh, anyway, let's see if we can do this one-handed, Dave. Right, I've got this across. I can't do this one-handed, I don't think. Yeah, okay. Anyway, so have a look at this. The poor old meter is having conniptions. She's not happy. She's trying to read that. It's just such a low resistance on this meter. It's trying to read it. It can't. I thought, that's okay. I'm pretty sure I know what it is. But look at this. Decided to pull out this bit of kit. I was given this some time ago, and I've never unboxed it till today because I'm umming and ahhing. I thought I might give it away somebody else as a gift because it was gifted to me. Just down to somebody thought I might be interested. It's a smart multimeter. So not the now. If you're wanting a cheap multimeter, look for these online. If you want a multimeter, and the thing about this one, it's these new ones. It's one of these auto ones. You don't have to worry about the range settings or that. See this thing here where you got to set the ranges and all this one. It's an automatic one. It does it all automatically. All you got to do is turn the power on. You don't need to know what you're doing. You turn the power on. Look at that. It's in auto mode. And now I'm going to try and get this across here. Get this probes across. Look at that. It's having a bit of a think, and it's let me know that's 38.6 ohms, which is pretty much spot on. I reckon it was about, if you know about the tolerance of resistors, it's because it's in auto mode, it's doing the beep to tell me I've got a complete circuit, and it's measuring 38.6 ohms. No stuffing around with scales or setterings or anything like that. We might play with that over the next couple of days and let you know the results. So if you are looking for a cheap multimeter, have a look at this one. Check this one out. Auto. Don't have to worry about the scale. So if you've got any questions about that, let me know. It's not a paid review. I'm not a paid review. It was given to me. It's something to play with. I got some other stuff that I was given at the same time. There's an oscilloscope which came to me broken and I fixed, and a few other bits and pieces came from this same brand, so we haven't played with it. How about that? Sorry, old girl. You've served me well, you've done stuff, but you might be relegated to the spares box. You might have to go. Replaced by the latest and greatest. These things, if you know what you're doing, if you can measure DCC voltages and bits and pieces, check. Very handy if you know what you're doing, how to use one. But look at that. I've still got, we won't go into too much, I've got my dad's multimeters over here. How about this? This is an old analog. You had to know how to use these things, or you blow them up, and then you had to adjust them and all that. That's little one. They came from Radio Shack many years ago. Tandy. Look at this one. I'll show you this just out of shits and giggles. There's one here, which look at that. This is a proper old school multimeter. So this was Dad's that he because he was all in a lovely case, being a chippy. It's got his name, Nostalgia. Case, got his name in his handwriting down on the case. He's made it up a lovely little case. Use that. Beautiful old school. Kept that. Once again, you've got to know what you're doing with these things. Very easy to destroy, blow up. Lucky a lot of them had fuses. You've got to zero them out. If you knew what you're doing with these old things, you could measure all sorts of stuff. including dwell on a car. That's the thing you've probably not heard about in news. You could set the dwell timing on your car if you knew how to use one of these old fellas. Anyway, that's nostalgia. How about, look, this is me hoarding stuff. There is under here, we'll pull it out. We'll have a quick, this is not sponsored. So this is from this same mob. You can find this stuff cheap. That is a oscilloscope. That was sent to me by somebody who had bought it and had damaged, and I patched up and got it working. And there's another meter in here as well, which is a meter and oscilloscope and all that in one. My older brother's probably watching this and going, well, you got them. Anyway, in the box. If you want to know about those, let me know. We'll do some reviews. Unpaid, unsponsored, but there you go. Tech order Dave. Anyway, yeah, I'm going to go and order some off the interwebs, order some diodes and bits and pieces. Not diodes. My brain. Going to order some resistors. We'll get back to you. You wouldn't read about this, folks. Wednesday morning. I've already had one trip of Bunnings to Bunnings today. I had to go to Bunnings and buy a hose connector because up here on this, I still haven't got it perfect. I have to try and tighten it up. I'll do something here. Hose connector here keeps leaking. Well, it was split in two, so I put a new one in and it's leaking. So I've got to try and tighten that up. I might have to cut the hose squarer. That's a newer hose line. That's an older hose line that was already existing. I might have to climb up there and cut it off square and try and get that tight. But I've got that running. I've got water up my line. Got it all supplied. Hose is split somewhere else. I'm not having another trip to Bunnings today, so that'll have to be a tomorrow's job. But I've got the spray heading in a direction that's going to be useful. I will get the water where I want it to be, but hey, hope you can see that in the video. Can't take a trick today. Anyway, getting water on the pretty flowers, so that's the important thing for today's project. But wouldn't that rot your socks? Wouldn't that put a hole in your trousers? Huh. I just seem to be spending half my days chasing irrigation leaks at the moment for this magic system that I've put in that may be too complicated. Either that, I might be trying to pull it all out and start again. Anyway, just thought I'd show you that. Isn't life fun? Yeah. Isn't life fantastic? Well, I've ordered a whole heap of stuff from Jaycar yesterday. Some assorted resistors to try and sort out the issue we had with the street lights to get that done. Some other bits and pieces, some cable and all sorts of stuff. Anyway, I do now need a new soldering iron tip from the soldering iron, but yeah, okay. Always happens that after you put the order through that you do that. Plan today, I've also got stuff coming from China, which is all the extra LEDs we've ordered. So while we're waiting for that, I thought in the meantime I will crack on with what gear I do have on hand. What I'm going to do today is I'm going to extend the 6-watt power bus, which runs all the town supply in the buildings, from this point here underneath this shop. And I'm going to run a line up to the under the ground, drill a hole, run the cable through underground, fancy town, we're going to do underground cabling, up to the fire station, which I'm going to have a terminal there, so the fire station will go in there, and then going to run, hopefully, well, depending on how well I go, a line up into the bottom of the servo, and hopefully I put some lights in the tram cafe. So that is the plan for today. Just thought I'd show you that in an update, and I'm going to crack on and we will have a look at this. Probably want to get it all done. Show you up to, but yeah, so that is the plan for today, Wednesday, is to run a power bus underneath all this that will supply the rest of the lighting circuit in this area of the layout. We still have no lights over in the depot area, so that'll probably be a separate. We have got lights and a supply bus up to the other end to supply the layout. The last place that isn't has any lighting at all, and that'll be the last stage we do, is that area, which is the old depot. And I have a plan to put lights in the new warehouse. We'll see how that goes, but let's crack on with what the plan is for today, and I'll chat to you soon. I often say that one of the funny parts of this shed is in the opening. Come with me, because we might make stuff or break stuff. Well, guess what, folks? Broken here, the old step drill. Got this, well, look, I'll just stick it over here. From Aldi, cheap and nasty. Not sponsored in any way by anybody. How about that? Ruin the shot. So the old step drill from Aldi, I've broken the tip off it, just drilling through me baseboard. But that's okay. Very lucky. Other week when they were on special Audis, I grabbed another set of them because they're so handy. The old step, they magic. Once you use step drills and stuff, magic. But anyway, I've broken the tip off that one. Little fella there. It's meant to have that tip on the end of it. It's gone. And I'll tell you why. Wouldn't that rot your sock? It's just where I wanted to drill the hole down through the fire station. You'll never guess what's right underneath there. Let's go and see if we can have a look. A beam. Whopping big beam. Right underneath, we want the cabling to go through, so I've had to get out the speed bore and go right down through the lot. Fun and games. Right, so yeah, I'm going to get back to I just want to show you that. Because people say, oh, we watch your videos, we don't break much stuff. But yeah, today we're having a break. Anyway, I'll run some cabling. I'll show you where that goes, because then you'll see probably better in a visual of where I wanted that cable to go. So here we are. I've drilled all my holes. I've cut out my chocolate blocks, or terminal spaces, also known as, because a lot of them used to be an old chocolatey Bakelite colour. They're often called chocolate blocks in the Sparky world. So I've pulled this cable through that goes underground over here under this building. I'll show you all when I've got it done. Goes underground there. The cable pops up here, and then there'll be a loop through the terminal block at each spot. I'll show you when I've done it. And I've got to come back and vacuum, but I thought I'd show you after that. So that is the hole underneath the servo for the lights in the servo building. There will also be lights, hopefully, in the servo concourse when I work all that out. But this is where we're up to so far. I'll allow to do the servo concourse, but I won't actually do it yet, because I might have to do some jiggery pokering to get the cabling in. But anyway, I'll show you that when I get that done. Might need digging a pit underneath the servo yet with the magic little router tool when we get that all worked out. But anyway, that's a job for not today. This is the job now, to get the wiring done for the lighting in this area of town. Now, I'll show you what I was talking about of having to drill down through that beam, because that's the top side. Let's have a look at Underworld. So this is the cabling Underworld, but look at this. I'll see if I can get the camera in there. Probably can't see it. Hang on. Let's go the other side around the toolbox. Around the tool tray. See that cable there? That's the cable there, but look at this. Right down the guts of that 2B1, which is the old edge of the old module. So yeah, good one, Dave. So we had to come right down through that with the speed ball. Spade drill, or whatever you want to call it. Everybody calls them different things, but I've called them speed drills. They're being called speed balls. But anyway, that is the cabling. Now, I've got extra cable here, so once we get it all done, we can pop it through. That's always good to have a bit of spare. But anyway, onwards and upwards with the wiring up of this section of the layout after I do some vacuuming. I've only had 1 cup of coffee today, so that may explain a few things. So here we are, end of the next stage. I've stripped all my cables off. I've stuck them in the terminals, screwed all the terminals up. Use that. I use a good old pair of cable strippers, and by old I mean old. Don't have to. Funny story about that is I worked with a bloke years ago, and every different boss you work for has got different ideas. I worked for a guy who was a Dutch guy years ago who hated people using that type of cable strippers. He was a cable knife only fella. He insisted that as a Sparky, if you worked for him, you did all your cable stripping with a cable knife. Now, doing that, it means everything has to be perfect when you're cutting off your insulation with a cable knife, because if you nick that conductor, game over, start again. So it made sure that you had to be every termination to be perfect and very neat. So there was some method in his madness, though I hate them. I hate using a cable knife. But anyway, working with that dude, you had to use a cable knife. That was it. I prefer me older strippers. Now, why have I done it like this? Somebody's going to ask, why have you done that? Up till previously, I've done this on some of the bits and pieces, but most of the places I run my wiring bus underneath and solder my lights on. Well, this is a non-solder method. Thought I'd show you this way. This is for somebody who can do it really quick and easy, who's not interested in soldering, not very good with soldering. So you can just run it like this. So this is a no soldering method. There's no fancy tools required. I've used, well, fancy cable strippers, but that screwdriver run me cable bus through. Now I haven't done my connection down here. The cables are sitting out. That's my next job, to put my connection in here. Reason for that is, any old Sparky will tell you, you always do your live termination, even though it's not live. I will prove I know it's dead because I've got the power, but you prove it's dead. You always do this end part connecting into your main system last, because it's just safer. So you're not accidentally tripping over yourself. You're not livening up bits you really don't want live yet. So you always do your main supply connection. So this will be where our supply point comes from, last. Don't do it first, always do it last. I am trade qualified Sparky, by the way, people. We've spoken about this before. People say, oh, you shouldn't be messing with power stuff. Up here on the wall, up there on the wall, see that? That says that I'm a certified nutcase. No, that's me electrical trade certificate. Now I have 3 trade certificates. Surprise, surprise. All in the electromechanical world. I have an electrical trade certificate. Now I have an electronics technician trade certificate, because in the old days you could do what they call PTE, post-trade electronics, which is an extra study course after you did your electrical trade course, and then you got your certification in electronics. So I've got that. And then I went on and I did a dead trade. You know how they talk about trades that are dead? Well, I did one of those. I have a trade certificate in a trade that's not even offered anymore. Fair enough, there are electrical tradespeople, they still do electrical trades through TAFE. I have a computer support trade certificate. Yep. Back in the old days, we used to have tradespeople that fixed computers. Not take it into a shop and they whip out the card, put a new card in, or replace bits and pieces. Back in the old days, and this is back about 1998 when I was awarded my trade certificate. Yeah, and 20 years ago they stopped doing the trade. They don't teach you the trade. So we were trained in how to actually repair big computer systems like mainframes, you know, the old IBM mainframes and bits and pieces, but it was a computer trade, and it was called the Computer Trade Support, Computer Support Certificate. Anyway, we were the Sparkies. We were qualified Sparkies who were also qualified to do computers, to repair at board level computers. Anyway, funny story. I've only ever met in my time one other bloke who actually was qualified in the computer trade certificate. Most of those people who work in shops and computer shops, ask them what qualifications you'll find. A lot of guys working on the computers and the tech, apart from the big engineers who do university degrees, a lot of people working in the IT field have qualifications on the ideas and the systems, you know, cyber security and all that, and all these vertical ideas. Programmers are a different thing, but when it comes to the electronics level of the computers, yeah, none of the guys, you don't need to. Plug and play. Anyway, I'm going to crack on and we'll talk about the next bit after I've done it. Well, there we go. I've got the connection under that building there. I was going to take some video of it before I actually put it together, but I thought, no. we'll put it all together and show you. So so this line is all wired up and in and commissioned. Pulled out that fancy multimeter. It's showing me that is live. We have DC around the 5 volt. I'm going to actually adjust that up because I actually wanted about 5.5 volt, closer to 6 volt. But anyway, we've got 5.125 volt there. The supply is adjustable. I do want to bring that up to about, well, I actually might even go 5. Doesn't really matter. No more than 6. We might anyway, that'll do. Let's not mess around. Now, the important thing with the multimeter is I'm just checking with the meter that, and you'll see that I've stuffed up here and I've got to adjust some cable because it's reading 5.5 volt. But have a look at this. The importance of using a meter. Polarity's wrong. That's why I'm checking with the meter. Because if you look at the red wire, oh, come on, Dave, you get the meter. This is the red. Oh, trying to get the leads down the road. Doing this. The red cable, black probe. I've got the polarity around the wrong way. So we always check at the last minute. So see the cable that's got the red on it. If I actually put the red probe that way, red to red, see that? That minus symbol on that meter means that the voltage is minus, which is not good. So I've reversed the polarity on my connection on my main line. So I've got to go and stuff around and change that. Good one, Dave. Good one. Right, problem fixed. 30 seconds fixed. Now, that's really not a major drama, but I do like to get it spot on. So now my red cable, red probe, red cable, I don't know if you can see it down there, red cable, red probe, 5.13 volts on the meter. That is fantastic. If you're using the old AC, like model railway accessory buses used to be AC, wouldn't matter. Using DC at 5 volts. Now, if I was using incandescent lamps, which very rarely these days, everything's LED powered, using the old torch type lamps, wouldn't have mattered. Using LEDs, well, in some ways it really doesn't matter, but I like to be precise. But there's every now and then light emitting diodes, if you get them around the wrong way, they just don't work. Being a low voltage bus, being a 5 volt bus, putting the LED in backwards, it just won't work. But there are some fancy electronics that I will run off the bus that if I connected them up there to the wrong polarity, it would let the magic smoke out. For example, the gates. The gates that I use, controllers for the gates and bits and pieces over here. If you haven't seen before, the opening and closing gates. If I reverse polarity those gate controllers, they let the magic smoke out. Learned that one. I let the magic smoke out. I've got a loose joint under here I've got to fix too. For the gates. Anyway, I learned about letting the magic smoke out of those. Yeah, it wasn't by reverse polarity. It was over current. I was playing around with one. Didn't have one of those current protection limiting resistors on the line, and yeah, let the magic smoke out of the controller. Good fun. Anyway, time for coffee. Dave's going to have a coffee. Then I'll chat soon. May not be show you what I'm doing today, maybe tomorrow. But anyway, that's it for what I'm doing now with setting up that wiring bus. And I've got to replace some buildings and do some bits and pieces. But anyway, talk later. Coffee time. Stop banging your gums, Dave. Well, this is Friday. Time to shoot a bit of a conclusion video and wrap up this week's video. Hope you did okay this week. Hope you had some fun. Just want a few quick things to show you. The flying duck, the Grumman duck. Not sure if it's a duck or a goose, but the mighty Grumman finally, instead of sitting on top of the buildings there, I thought, look, I better find some old fishing line and suspend it as a salute to the old pickled parrot. If you know the old Pickled Parrot Airways and the old Pickled Parrot layout that I'm referring to, that's a homage to the parrot. Yeah, a couple of things to quickly show you. Running around the layout, yes, trains do run occasionally. 3415, which is a 3/4 New South Wales 422. There is the full-scale NJ that you've seen me build. This is once again in that line. I love the dual cab locos. It's been out of service for a while because he blew up his DCC chip. Cleaning up the other day when I was going through my electronic parts, I found a DCC chip in my box of magic parts. I thought no harm installing that in the loco and see if it works. It does. Pulled down the bit spin when I was ratting around for old resistors. You have to watch the last few videos to find out the story of the resistors. Anyway, I soldered that in and it's alive and well. The only hassle is I have to sit down and modify some of its CV configs, about DCC stuff, because the thing is it's almost undrivable. Can't remember what that particular DCC chip comes down of, but it's go or stop. The settings are take off like a rabbit or nothing at all. Doing some recommissioning laps at the moment, but it takes off like a wounded bull, like the old scolded cat, and the power is off. There's no two settings, so I've got to sit down and do some reprogramming of that, because whatever it was in, the settings don't work in that chassis. That is an old version Bachmann GP38-2 chassis, the old one, which was pre-DCC. I then at some stage years ago put a DCC chip in it, which then later on gave up the ghost, let out the magic smoke, and it's no longer working, but now it's back in action. These days I'd buy the Bachmann chassis that are DCC chip installed. Anyway, isn't it amazing that we can get electronic parts out of China in 4 days delivered to Australia, but I can't get stuff from the next town over within about 7 days. I've ordered some stuff from Jcard, and apparently it's got to go for a bit of a world tour before it gets to me, and I've got some stuff coming from China which should be here Monday. Both ordered on Monday, or whatever it day this week. Anyway, quickly to show you what I've done. I have put some lights. I wasn't going to, but I used stuff I had on hand, trying to sneak down here, and it's not perfect, still needs some work, but look at this. Hang on, pull the crane out. Put some lights in the old fire station. Yes, I know I've got to rearrange the cabling, pull down the road, but anyway, there you go. And I pulled some of the red LEDs I had out and stuck them in some of the old lampshades. Anyway, you get the effect. Anyway, that's it for this week from Dave in the Shed. Hope you come back next week, drop in for a visit, and we'll have a chat about what's going on then. Till then, keep yourself safe, keep yourself well, keep the old noggin stimulated, and the best way to do that is to do something. Even better is to have a crack at do something new that you haven't done before. In the words of Mr. Henry Ford, if you think you can, and if you think you can't, you're right. Anyway, I've been Dave in the Shed, been a lot of fun. I've got to go off and edit this video up. I'm going to try some new editing stuff this week just to see how we go with that. Till then, catch you later. Don't forget, like, subscribe, comment, share this video with your friends. Got any questions, let me know. Till we meet again, I'll do a quick scan around the shed. Hey, have a look at this before we go. Have a look at this. Put the bench, the big uppy downy bench, away where it's meant to go, and I got my seat back, got my lounge back. Oh, one other project on, doing some snail houses. If you want to know about the snail houses, I've been printing up. Have a look at this. Got all my most of me. For those that saw water leaking out, we've replaced the line that was leaking. There's the old hose there sitting on the ground. You've got a new hose up in the air so the irrigation doesn't leak. And I've been working on some snails' houses. Yeah, the old snail ales pubs, if you know what they are. If you want to know anything about what I rabbit on about, let me know. We will inform you. We'll educate. Anyway, once again, till we meet again, take care, look after yourself. Try something different. Bye for now. Dave in the shed.